Good day to you all. Learner's Note is an online solution to encourage better ways of education among our students. I am Sanjana and I am your chemistry teacher. So let's discuss electrochemistry. You know what the term electricity means. It means flow of electrons. It is a very simple explanation. Flow of electrons means electricity. But then what happens during flow of electrons is very important. There are different kinds of effects that is created just because of the flow of electrons, which are very tiny, which is actually we might feel that it is very insignificant, but then that small flow of electrons can actually lead to a lot of changes. There are different types of effects that are created because of the flow of electrons. For instance, you have heating effect of electric current. For instance, you can take the light bulb. The light bulb produces light energy just because of the heating effect of electric current. Similarly, you have magnetic effect. If you have an electricity passing through iron piece, then you can actually turn it into a magnet. So that is an example for a magnetic effect of electric current. Similarly, you have chemical effect of electric current. So in chemical effect of electric current, what happens is you have electricity passing through a chemical solution and that will produce a chemical reaction. So that is what you mean by chemical effect of electric current. So the branch of chemistry which deals with the relationship between electrical energy and the chemical energy and how they are interrelated or how they are interchanging is what you mean by electrochemistry. Now we have something called electrochemical cell. Electrochemical cell is used to demonstrate the chemical effects of electric current. So basically you have two types of electrochemical cell. One is the galvanic cell and the other one is electrolytic cell. You can see the figure here, and from the figure you can easily understand that in galvanic cell you have two half cell, whereas you in the case of electrolytic cell you just have a single container. So this single container is called single cell, and here you have got two half cells. So that is one of the major difference between galvanic cell and electrolytic cell. And then here in galvanic cell what happens is you've got a reaction taking place, and that reaction, maybe a redox reaction, leads to the flow of electron, and that flow of electrons between the cathode and anode can lead to production of electricity. So there is a redox reaction taking place spontaneously in this container, and that flow of electrons leads to lighting of the bulb. So that indicates that just because of a chemical reaction you've got electricity. So that is what a galvanic cell is. Same way you have electrolytic cell. In electrolytic cell what happens is you have a source of electricity and you are switching on the source and you are passing electricity through the solution. So when you are passing electricity through the solution, what happens? There is a chemical reaction taking place. So that is another important but a basic difference between electrolytic cell and galvanic cell. Here what you see is because of the chemical reaction you produce electricity, whereas in the case of electrolytic cell you have a source of electricity and that produces a chemical reaction or a chemical change. So that is a brief introduction about electrochemical cell. Now let us see the basic difference between electrolytic cell and galvanic cell. Like I said, in electrolytic cell you have a conversion of electrical energy to chemical energy, whereas in galvanic cell the exact opposite is taking place. You have chemical energy and that is converted to electrical energy. So here you are supplying electrical energy, that means there is an external force, whereas in case of galvanic cell you have a redox reaction which is a chemical energy that you are supplying. The reaction can be spontaneous or you can make the reaction spontaneous, you can give extra energy but not electrical energy. But then when there is a chemical reaction you have electrical energy produced. Then another important thing is here in electrolytic cell you have cathode as negative and anode as positive, whereas in galvanic cell the exact opposite is there. And then in your electrolytic cell you have cathode where oxidation takes place, whereas in galvanic cell you have oxidation taking place at anode. And like I said, as I mentioned earlier, in galvanic cell you have got two half cells, that is there is a partition between the container, or there is a two half cell you can say, whereas in electrolytic cell you just have a single container. So that is another important difference between electrolytic and galvanic cell. And when you are talking about in terms of uses, you have got electrolytic cell, which is used for electroplating and electrolysis purposes, whereas in galvanic cell you are using it in batteries that you use in your daily life. Okay. Now with that we will move on to the next topic, which is batteries. In batteries, you know, the basic idea of battery is that you are connecting few galvanic cells together, and that will give you what is called as battery. Now again, battery is classified into two categories. You have got primary battery and then you have got secondary battery. In primary battery, what happens? Your reactants are converted to products, and once that reaction takes place, there is no going back. You cannot reverse the reaction. So once you have utilized all the chemical energy that is stored in your primary battery, it is good for just throwing away. But whereas in the case of secondary battery, you can actually reverse the chemical reaction that has taken place, so that you can use it multiple times. You know the example for primary batteries, actually the batteries that you use in your watch, your clocks, your remotes and everything, those are simple primary batteries, you cannot reuse it. But then the secondary batteries, example would be lead storage battery, that you can actually recharge, the one that you use in car, or inverters that you can actually recharge are called secondary batteries. Then we move on to the application of electrochemistry. There are two major applications of electrochemistry. The first one is electrolysis and the next one is electroplating. Electrolysis is a simple method to demonstrate the chemical reaction and the effect of electric current on the chemical reaction. In electrolysis, what happens is you are decomposing the ionic compound. In electrolysis, the important thing is that the liquid or the electrolyte that you take has to be ionic in nature. Okay, so this is how basically an electrolytic setup looks like. You have a container and you have two electrodes, one is anode and the other one is cathode, and then you have what you call as electrolyte. Now when you are passing electricity through this container, what happens? There is a chemical reaction taking place inside this. So the electricity is passing through and it's a complete circuit. So what happens? Your ionic compound will start decomposing, and the positive ions are attracted towards the cathode, whereas your negative ions are attracted to your anode. So you can see from this picture, it is actually very clear. You have got ionic electrolyte, and then you have got a cation which is attracted towards the cathode and anions which are attracted towards the anode. So electrolysis is a simple process wherein decomposition of ionic compounds take place just by passing electricity through them. Okay, and you have a liquid electrolyte, that is also very important. Here cations are reduced at cathode and anions are oxidized at anode. So that is a simple demonstration of electrochemistry. Another important application of electrochemistry is electroplating. Usually when you use metals like iron or other easily corrodable material, what happens is after a few usage of that material for a few days or months, what happens is it is prone to corrosion or rusting. So in order to prevent that, or in order to make the life of that particular object long, what we do is we do electroplating. So in electroplating, what happens is you are electro depositing another material which is less prone to corrosion, so that the life of that object can be increased. So in electroplating, what happens is you have a container and you have an electrolyte, just like as in an electrochemical cell. Then you have an anode and a cathode connected to a power supply. In this, what happens is you have to keep in mind that the cathode has to be the substance which you are trying to electroplate, and anode has to be the substance which is a material that you are using for electroplating. So that is an important point that you have to keep in mind. So once the setup is ready, you switch on the power supply. Once you switch on the power supply, what happens is you have electricity flowing through, and once the electricity is flowing through, your electrolyte will ionize. The decomposition of the electrolyte will take place and you get the ions. Now what happens? These ions are transported from your anode towards the cathode. So there is a deposition of material which is present in your anode on to the cathode. So what happens? You get an electroplated material. Now the thickness of your electroplated material depends on a variety of factors, like how long you are conducting the experiment. Like if it's for a short duration, you get less thickness. If you're doing it for a long duration, then you get a greater thickness. That is one thing. Then it depends on the concentration of the electrolyte as well. If the concentration of electrolyte is very strong, then the deposition will be obviously more. But then if your concentration is less, you won't have much of a deposition. Then another factor that you can say is maybe the amount of energy that you are supplying. If the intensity of the current that you are passing is quite high, then the deposition will be more compared to the other. So this is what basically happens during electroplating. Some of the most commonly used materials for electroplating are nickel, chromium, palladium or an alloy. Then you have gold, silver and copper. Gold and silver being very expensive is not commonly used for electroplating, but it depends upon the purpose. If you are trying to make jewelry, then definitely gold and silver is used for electroplating, but otherwise usually chromium is the material that you are using for electroplating. So this is a brief idea about electroplating and electrolysis. I hope the concept is clear. Now in order to make it much more understandable, let's conduct few experiments on electroplating and electrolysis so that you get a clear picture of what is happening during the electrochemistry process. Let us now demonstrate the principle of electrochemistry using two experiments. First, we will see the experiment of electrolysis. So the materials required for this experiment are a clean beaker, water, concentrated sulfuric acid, which is for increasing the conductivity. Then you need two electrodes. Here we have taken graphite electrodes and a stand. Now to this you need a power supply. So these are the materials that are required for electrolysis process. Now let's see how this experiment is done. First we take a clean beaker and add water. Now we add few drops of concentrated sulfuric acid just to improve the conductivity of the solution. Now the next step is to insert the graphite electrode to the stand and keep it on the beaker. Place this inside the beaker. The next step is to connect the crocodile pins, which is source of our power supply, to the electrodes. Now let's switch on the power supply and see what we can observe. Now you can observe that there are bubble formations in this setup. So this bubble formation indicate the decomposition of water that you have taken in the beaker into hydrogen gas and oxygen gas. That is the bubbles that you observe near the electrodes. So this experiment actually demonstrates the effect of electricity on your solution. The next experiment that we are trying to do is electroplating. In this, the material required are a beaker containing water, copper sulfate which is hydrated, you have a spatula, then you have two electrodes, one is copper and the other one is steel, then you have a stand for holding the electrodes, and then you have a power supply. Now what we do is we take the beaker containing water and then we add a small quantity of copper sulfate into this solution, and then we mix it thoroughly so that it is completely dissolved. To increase the speed of the reaction, what you can do is add more quantity of copper sulfate to the solution, okay, to increase the speed of the process. Now, once the mixing is done, you can take the electrodes and fix it to the stand and then insert it to the solution. We have two electrodes, one copper electrode and the other one is steel electrode. Now, you slowly and carefully insert this into the solution. Now, once the setup is ready, we can connect it to the power supply. Now, let us switch on the power and see the reaction taking place. Here, we have connected anode to the copper rod and cathode to the steel rod. So, here the material that you are using to coat is copper and the material which is to be coated is steel. Now, you can observe that copper has started depositing on to your steel rod. Here what basically happens is copper from your copper sulfate solution is being continuously deposited on your steel electrode, while the copper from your anode is continuously dissolved into the solution. So, this effect can be observed on passing electricity to your solution. So, this is another way to demonstrate chemical effect of electric current. Dear students, I hope you've had a fair idea of what is happening in the video, that is the topic electrochemistry. Learners not believe in learning concepts by doing experiments. We have many such experiments related to your syllabus. So, keep watching our videos. Please visit us at www.learnersnote.com to explore a whole new world of learning with fun. I am Sanjana, your chemistry teacher, signing off.